Hi, I'm Sam Newman. I'm a consultant, author, and speaker. I focus mainly in the area of continuous delivery, microservices, and the cloud. I'm doing a talk about the word asynchronous. It's a word we use frequently when talking about how services communicate with each other. But I became very aware when trying to understand what that word means to people that there are actually lots of definitions about what asynchronous means. So many different conflicting definitions that the term itself is actually useless. And so I'm striving in my talk to find more specific terms that help us communicate better as teams so that we're all on the same page. Some of those ideas, like gRPC, are quite popular at the moment, but they're based on fundamental concepts we've had since the 1980s. I think what people are often aware of is the latest shiny implementation of these ideas, but they often lose sight of the more fundamental different styles of communication. So there's a fixation sometimes on, oh, I'll use that piece of technology because everyone else is using it, without necessarily thinking through the implications of, for example, picking an RPC style of communication versus maybe looking at a more invented style of communication. And I find that this can happen as much with experienced teams as less experienced teams, because we often bring our preconceived notions. So when I'm talking to people and we're trying to understand how these things should best communicate, I try and start with those stylistic differences first, the fundamental differences between, say, a request-response oriented communication versus event-driven. And then once you've worked out which of those styles suits your problem space the best, that then also limits your solution space. If I'm looking at event-driven interaction between two services, I'm highly unlikely going to consider, for example, gRPC. I think in terms of things being hyped, gRPC is very popular at the moment, but I can understand why. I think there's a lot of organizations and people who were not really using REST over HTTP well. They were basically using REST over HTTP as a bad form of RPC. And so for them, gRPC is better. Likewise, I see a lot of interest in Kafka continual. In fact, that doesn't seem to wane, because it solves, I think, some legitimate problems that we're increasingly having. As we distribute our computing more and more, and as data becomes more important, we're faced with the challenge of how do I move data around my systems more easily. Interaction mechanisms, technologies like Kafka, help us do that in fairly efficient ways. Although again, from a developer point of view, you can't just view Kafka like being another type of message broker, because it is a bit different. So I always like to start with what problem you're trying to solve, what kind of outcomes do you want, and then use that to then assess the technology, rather than I've picked up the shiny technology, oh, it looks like we're working in the way this tool now wants me to work. I think you're seeing a lot of people that are quite new to working in a more distributed system environment, partly because of the inappropriate success of microservices. There are lots of people doing microservices that shouldn't be. So where you're seeing teams that are maybe not used to working in kind of more network connected environments, they may be less aware of some of the fundamental challenges that we experience. I really distill all the challenges of distributed systems down to two kind of key constraints that are unavoidable. Firstly, you cannot beam information instantaneously between 2 points. You can't, it takes time. And secondly, sometimes the thing you want to talk to is not there. People who have worked with distributed systems for a while, whether or not they would explain them the same way as I have, they understand these things in their bones. They understand when I make a call to something, the thing I'm talking to may not be there. It might be there, and it might respond slowly. So they understand how to think about, well, do I need to retry? Do I need to do a timeout? They'll understand about issues around things like idempotency. A lot of less experienced developers in that distributed system space may not have been bitten by these things. They may theoretically know that these challenges exist, but they haven't lived them or be hurt by them. And some of them are often suckered into using abstractions that will claim to take the network away, so they can pretend the network doesn't exist. And I think they tend to get a rude awakening when, in production, weird stuff starts happening. So if we're trying to make a more resilient system, I think it's important to not view it as a journey, because a journey implies we do some traveling and then we arrive at our destination. And once you've arrived, we no longer need to travel. I think building a resilient system requires that you are continually thinking about how to improve the resilience of your software. Once you get a system that is robust and resilient, the world keeps moving around you. You need to keep on top of it. It starts with things like timeouts, retries, idempotency. These are your bread and butter. It's the way you get started. But you need to see it as a continual part of how you build software, rather than thinking, it's stable now, our job is done. It's actually rare that I see people make things too resilient. I think what I often see people do is put effort in the wrong places. Sometimes this becomes about because of miscommunication. They're not able to talk to users about their real needs. As developers, we might intrinsically know we need to make this system more resilient or more robust, but without some framing that comes from having the right conversations with the user or application, our effort gets diverted into the incorrect places. So it does come down to getting good at having the conversations with a user of your application, like, when does this need to be available? What's the impact if it isn't? And then being able to take that information and convert that into requirements or targets that are measurable for you. Left to their own devices, developers don't want to make unstable applications. They're going to put energy into it. The question is that energy going into the right place? We often encounter the giant decks of non-functional requirements that are going to guide us through all these things that are often not expressed explicitly as user requirements, and measures around reliability and resiliency sometimes occur in those areas. But often the challenge is when you're looking at the non-functionals, it's like you've got so many ilities to look at, this huge deck. Wading through it becomes really, really difficult. As a result, we can often get lost in the weeds a little bit. It's rare that I find the requirements around the resiliency of a system is well expressed in ways that both make sense to the users and the owners of the application, as well as for the developers. You can't necessarily have one expression that makes sense to both sets of people. A user might talk in terms of the application needs to be up during the working day. If not, it's going to cause me real trouble. I'll get shouted at by my boss. You'll have conversations, you'll get more to specificity, and then you'll suddenly have a requirement for a developer can work against, which is we need a 99.9 percentile latency response time of 500 milliseconds. Right? That's a very developer-focused and measurable thing, something you can use as an SLI, target your SLOs. No end user is going to give you that number. So you have to have the conversations, understand the needs, and interpret that into ways and measurements that are measurable and actionable, and ideally, increasingly, is something you can incorporate into the SLOs of your team, and therefore can become parts of things like error budgets. One of the things I'm working on at the moment is looking kind of more broadly than microservices, but also a bit more narrowly as well. I'm working on a book about how to build resilient distributed systems. And these are often boring, dry topics like retries, idempotency, and everything else. But it also looks at the people, the behavioral aspects, the importance of psychological safety, creating a learning environment as well. And you need to approach things from multiple avenues to build that more resilient, robust system. It goes beyond just microservice architectures, looking at other types of distributed systems as well. I'm writing the book at the moment. The goal is for it to be in print in early 2025.